We introduced MeshChain Secure 3D Model and Intellectual Property Management powered by blockchain technology. Three-D model became an important data in many fields, such as biology, art, and design. But its intellectual right is vulnerable to tampering and plagiarizing when being spread through the internet. Therefore, we need a reliable platform for storing and tracking the 3D data, and also storing and tracking the 3D model's history and information. Our idea is to construct a 3D property management platform on the blockchain-based decentralized network. In detail, instead of storing the 3D model and its information on the single central server, we store the copies of the data on the many computers on the network. Traditional networks are usually based on centralized network. In the centralized network, the data depends on the single central server. So, the data can be damaged if the central server suffers from failure or attack. Now let's talk about the decentralized networks such as blockchain. In the decentralized network, the copies of the data is distributed on the many nodes. So, when some nodes are down, the data is still safe since other nodes are still alive. When a data on the node is changed illegally, it won't pass the blockchain's validation method running on other nodes. So, those nodes will reject to apply the malformed data into their own databases. The core point of our work is the proposal of a decentralized 3D property management platform. We expect our work to give several benefits to 3D property management. For example, our work shows that we can develop various 3D applications, such as cooperative 3D modeling platform on a decentralized network. Our work provides a way of building a safe and transparent 3D property management and protection platform. Our work heavily depends on the blockchain, such as Ethereum. It started from a digital currency system on the P2P network, but it became a platform for developing various kinds of decentralized applications. So, anyone can utilize the power of decentralization when building an application on blockchain. Our work also depends on the decentralized storage, such as Swarm. It is usually called content address storage. In detail, unlike traditional clouds, each file's address is constructed on the hash of the file instead of the server's address. So, when we want to attach a network storage on the blockchain network, which is an anonymous and decentralized network, decentralized storage will be easier to attach to blockchain than centralized storage. There have been several works on cooperative 3D modeling, such as diffing and merging algorithms for 3D models. Some works tried connecting the 3D modeling tools through the network to construct a 3D collaboration platform. Previous work showed the possibilities of 3D collaboration, but they paid less attention to the data security and intellectual property. Compared to those works, we concentrate to the data security and intellectual property of the 3D data. Some works propose decentralized version control by using the blockchain network as a backend for Git. 3D collaboration is similar to code collaboration, but is more challenging. In 3D collaboration, we submit larger data more frequently. In our work, we adopt specific technique to reduce the network load of 3D collaboration. There exist some platforms that provide distributed GPU rendering system based on blockchain and cryptocurrency. The user can perform other rendering tasks and receive the proper amount of cryptocurrency. Our work fills the missing gap by tracking the history of modeling process on blockchain. Our idea is to connect between the 3D modeling tool and two decoupled decentralized networks, blockchain network and decentralized storage network. We use the decentralized storage network for storing the 3D data itself, and we use the blockchain network for storing the data's address. Why do we use two networks together? 3D data is too large to store directly on the blockchain. Blockchain usually requires cryptocurrency to store the data. The cost is not large if the data is small, such as a text. But the cost usually becomes extremely large if the data is very large, like a 3D model. So we use decentralized storage together with blockchain. Decentralized storage is not as flexible as blockchain, but it is better at storing a large and immutable data. We store each 3D data on the decentralized storage first, then the data will have the storage address. So we store the storage address of the 3D data on the blockchain. Using such design, we can implement commit and checkout operation, which work similarly to the version control systems. Suppose that a 3D designer edits the 3D data and submits it. The data will be stored on our decentralized network, so other designers can download it and apply their own works on that. Commit operation consists of three processes. First, we read the 3D model from the modeling tool, and we store the commit data on the decentralized storage. And then, we store the storage address of the data on the blockchain network. We can regard the storage address as a commit address. We propose a performance boost strategy called the mesh page. Instead of submitting the whole mesh to the network, we calculate the difference of the triangle sets between two versions of the 3D data. Since the difference itself is a triangle set, we compress it using existing 3D compression algorithm. We will show later that this strategy increases the performance for commit and checkout operation. We can construct an incentive system on our work, called the mesh incentive. Modern blockchains such as Ethereum supports storing the cryptocurrency on the network via smart contract. Using this, we can create a system which automatically gives the cryptocurrency when a user makes a contribution to the 3D data. Let's see our concept. The project creator stacks some cryptocurrency on the network when he or she creates a new project. We can define a smart contract which gets a 3D modeling commit as input and calculates and sends the proper amount of cryptocurrency to the user. So when a user makes a contribution, the blockchain will automatically send some cryptocurrency to the user. There can be various methods for calculating the amount of incentive. We provide a simple formula which can be used as a base for constructing the various incentive policies. Some users can add and remove the same triangle many times to get much incentive. Our formula is safe from that situation. And our formula guarantees that anyone who modifies some triangles gets non-zero incentives. Another application of our work is 3D model authentication. We can combine the existing 3D model similarity algorithm to build an intellectual property database for the 3D others. So anyone can easily find out that the 3D data from the internet is plagiarized or not. We implemented a prototype of our work by connecting Blender modeling tool, Ethereum blockchain, and Swarm decentralized storage. The prototype implements the applications on Ethereum and its smart contract system. In detail, it implements the commit and checkout operation, so we can simulate 3D cooperative modeling. It also implements our mesh-based strategy and mesh incentive system. It supports comparing the 3D data from outside to the 3D data stored in the network by embedding the existing 3D model similarity library. Now we show that our mesh-based strategy gives a performance boost. We measure the average commit time and checkout time after turning on the mesh page and turning it off. The plot shows that the time spent for commit operation decreases after turning on the mesh page feature. The following plot shows that the time spent for checkout operation also decreases after turning on the mesh page feature. In conclusion, we can build a secure 3D model and intellectual property management platform powered by blockchain and decentralized storage techniques. It helps building various kinds of applications such as cooperative modeling and intellectual property management on the decentralized network. We can adopt the 3D specific strategies such as mesh-based to make the modeling process more efficient. Thank you for your attention.